the equation of vibration of a system subject to external forces is given by d squared x over dt squared plus 16x is equals to 16 cos 40. Use the method of undetermined coefficients to solve the differential equation given that when t is equals to 0, x is equals to 2, and dx over dt is equals to 4. Now for you to use the method of undetermined coefficient to solve this kind of differential equation, that is the D operator method, isn't it? So this D operator method, we need to find both the auxiliary or both the complementary function arising from the auxiliary equation and the particular integral, isn't it? So you let y to be equals to u plus v, where u is the complementary function and v is the particular integral. So here we don't have y, our variable here is x. You are used to y to be that, isn't it? So here you now let x, what is why you put x, so it is x which is u plus v, because x is the independent variable, isn't it? We are differentiating x with respect to t, so x is the independent variable, so x is equals to u plus v. Are we together? So from there, you now start the complementary function. Where there is x, the first part you put u, isn't it? So where there is x, if you put u, you are going to get d squared u over dt squared plus 16u. Then it is plus, the second part where there is x, you put v, it is going to be d squared v over dt squared plus 16v. Then the whole of that is equals to what? 16 cos 40. Are we together? So separate, the first part is the complementary function you equate to 0, isn't it? Then the second part is the particular integral you equate to the function. Are we together? So the first part, which is d squared u over dt squared plus 16u is equals to 0. That is the complementary function you equate to 0. Then the particular integral part giving us the particular integral d squared v over dt squared plus 16v is equals to the function you've been given, isn't it? So the function of t we've been given is 16 cos 40. That forms equation 2. Are we together? So let's start by solving equation 1. So equation 1 we have d squared u over dt squared plus 16u is equals to 0. So it means you substitute d with d dt, isn't it? So that will imply d squared is what? Is d squared over dt. So if you substitute there d squared over dt squared, it will be d squared u plus 16u is equals to 0. Then you now substitute d with m to give you the auxiliary equation, isn't it? So if you substitute d with m, you will get m squared u plus 16u is equals to 0. So if you factorize out u outside, you will remain with u into m squared plus 16 is equals to 0. So either u is 0 or m squared plus 16 is equals to 0. So m squared plus 16 is equals to 0. So those who understand the concept, that it doesn't need to go all that step. You just come here direct, isn't it? Are we together? If you understand the concept, you just come to m squared plus 16 is equals to 0 direct from the complementary function, so that you don't waste time with all these steps, okay? But this is general for you to be very procedural, okay? So what do you have? M is the square root of negative 16. If you take positive 16, the other side you get negative 16, isn't it? For you to get m, you find the square root of negative 16. So that is what? M is plus or minus j root 16. So root 16, you can get it on the spot, it is 4, isn't it? Because square root of negative 16 is square root of negative 1 times square root of 16, isn't it? Square root of negative 1 is j, square root of 16 is 4. So it means the solution of m is what? Only imaginary. We only have imaginary part only, isn't it? So when we have only imaginary part as the solution, it implies our u will be in which form? It will be in the form cos beta t, a which is a constant, plus b sine beta t. That means if this solution is plus or minus beta j, so you can see our beta is 4, isn't it? If we only have an imaginary solution, then this is the form of a complementary function, isn't it? Are we together? So where there is beta, can you put the value of beta? The value of beta is 4. So where you have beta, you put the value of beta. The value of beta is 4. Those steps I'm just writing for explanation, but you know there are steps you just ignore because you mastered them, isn't it? Are we together?
Yes.
We have found u. Let us go to v. We have found the complementary function. Let us go to the particular integral, that is Roman 2, isn't it? D squared v over dt squared plus 16v is equals to 16 cos 40. Then you come and check, isn't it? So you see, what is your choice of v? V, when you are choosing v, you don't look at complementary function. No. That is why you will go around. That's why you had a problem with the previous example. You see that? When you're looking for the choice of v, you don't look at the complementary. You look at the function itself. Are you seeing that? Don't look at that. You look at the function in this. Are we together? Is that understood?
Yes, sir.
Never look at the complementary function. Look at the function in that equation giving you the particular integral. The function here is 16 cos 40. So that 16 is, you take it as a constant. So it means that is a constant k cos 40. That should be cos 40, but you know cos is going with sin at the same time. Are you seeing that? So if this is k cos 40, so you make it k1 plus k2 sine 40. So after you found the choice of v from the function f of t, from the function you had there, it what gives you the initial choice of v. Are you seeing that? So after you've seen what you are choosing for v, if it is there is cos, you must have both cos and sin. Whether here is cos or sin, isn't it? Are we together? Then after getting the choice of v, is now when you look at the complementary function. After choosing v, is when you look at the complementary function. Then you check, is either cos 40 or sine 40 in the complementary function? That is what you check. It is there, isn't it? So when it is there, what do? You add a t to them. Are you seeing that? If it is there, you add a t to them. Then you check again. Is either t cos 40 or t sine 40 in the complementary function? No, it is not there. So it means this is the choice of v. Have you seen the way we are dealing with it? You check the function. The function is what gives you what you ought to have chosen, isn't it? Once you've seen what you ought to have chosen from the function, is when you go to the complementary function to check whether what you ought to have chosen is already there, isn't it? Meaning when it is already there, we no longer need it. Are you seeing that? Are we together? Good. So you start, this is v. So what do we need? We differentiate it until we get d squared v over dt squared, isn't it? Are we together? Yes. Start. So if you differentiate v with respect to t, this is product rule, isn't it? Are we together? You take cos 40 step and you differentiate t, isn't it? So you can make k1t to be one thing, isn't it? So if you take k1t, if you take k1t step and you differentiate cos 40, which one do you start with? Let us start by taking cos 40 step, isn't it? Cos 40 step. So if you take cos 40 step and you differentiate k1t, you remain with k1, isn't it? So you are going to remain with k1 cos 40, you took step, isn't it? Then it is plus, we are in this first part. We took cos 40 step, meaning we are differentiating k1t, we remain with k1, plus that cos 40 we took step, isn't it? Then it is now plus, we now take k1t step, we differentiate cos 40. Are we together? Yeah, what I'm trying to say, when you have k1t cos 40, this is what I'm trying to say. I'm trying to say, you let k1t to be u and sorry, it's not writing. You let k1t to be u, and this is v. So if you differentiate u, you get k1. If you differentiate v, you get negative 4 sine 40. So I'm saying differentiation by fact if you have ub plus ub, if this is u prime, this is v prime, isn't it? So u prime times v, that is k1 times cos 40, is what we have here, isn't it? Then it is plus u times v prime, k1t times negative 4 sine 40. Are you seeing that? So you get, what do you get? K1 times, it is u v prime. So this is u k1t times this. You get negative 4 k1 t cos sine 40. You've differentiated the whole of that. Then it is plus. You move to the second bracket. The second bracket you have k2. Look at the second bracket. You have k2t sine 40. So you can let k2t to be u and sine 40 to be v, isn't it? Are we together? So if you differentiate u, if you differentiate k2t, so you remain with k2. Are we together? Then if you differentiate v, if you differentiate sine 40, so you get 4 cos 40, isn't it? Then what are we supposed to have? uv plus uv, if this is u prime, the other one is v prime, isn't it? So u prime times v, u prime is k2 times sine 40, isn't it? So you get k2 sine 40, then it is plus uv prime, u is k2t, v prime is 4 cos t, isn't it? So it is plus this times this, that is 4k2t. 4k2t cos this times this, that is k2t times 4 cos t, you get 4k2t cos 40, isn't it? You're done. Move to the next one. You differentiate it for the second time, isn't it? You differentiate for the second time. So we are going to have d squared v over dt squared. So start. You can now open this bracket, isn't it? You can now open those brackets. So start. If you differentiate k1 cos 40, you get negative 4 k1 sine 40. Because differentiating cos 40, you get negative 4 sine 40. Then times k1, you get the whole of that, isn't it? Are we together? You are done with that term. You move here. See here, you use product rule again. So you use product rule again. Is that okay? You use product rule again. So you start. Here you have 4. You have negative 4 k1t sine 40. You want to differentiate this. So you can let negative 4 k1t to be u and sine 40 to be v, isn't it? So if you differentiate u, so you remain with the negative 4 k1. See, for negative 4 k1 is a constant. If you differentiate, it's 1, isn't it? So if you differentiate, you remain with the negative 4k, then v. If you differentiate v, you get 4, isn't it? Then product rule, if you have uv plus uv, if this is u prime, the other one is v prime, isn't it? Are we together? So if u prime times v, negative 4k1 times v times sine 40, what do you get? Negative 4 k1 sine 40. Then it is plus u times v prime. U is what? Negative 4 k1t times v prime is 4 cos 40, isn't it? So if you multiply this by this, negative 4 times 4? 16, isn't it? So you get 16 k1. You get negative 4 times 4 is negative 16 k1t cos 40. Are we together? Yes, so that one is going to be negative 16 k1t cos 40. You are done with that part. Move to the next part. So what you are done with, you take, isn't it? You move to this. If you differentiate k2 sine 40, remember that it is plus, isn't it? K2 is a constant. If you differentiate sine 40, you get 4 cos 40, isn't it? So 4 cos 40 times k2 plus 4 k2 cos 40. You are done with that. There was no product rule there, isn't it? So you come to the last one here. See, this is t cos 40. So that is product rule. See, that is product rule. So go to product rule. What do you have? We have 4k2t cos 40. So this 4k2t will let to be u and cos 40 to be v, isn't it? So when you differentiate u, if you differentiate this, you get 1. Because 4k2 is a constant, isn't it? So you remain with 4k. Then if you differentiate v cos 40, you get negative 4 sine 40. Then what do you know? You are supposed to have uv plus uv. If this is u prime, the other one is v prime, isn't it? So u prime times v, 4k2 times cos 40, you get plus 4k2 cos 40. Then u times v prime, 4k2t times negative 4 sine 40, you get negative 16. Negative 16k2t sine 40. Are you seeing you differentiated everything? So that is d squared v over dt squared, isn't it? Then remember your u must be somewhere because I need to use the other space. U is a cos 40 plus b sine 40. That was your u, isn't it? So let us use this space to deal with that v. So what do you have? Look here, we have d squared v over dt squared, isn't it? You substitute. See, the whole of this is its value. Try to simplify it by joining the ones which are the same. Have you seen the parts which are the same so that to make it more simpler? Which ones are the same? Sine 40. Look here. This is sine 40. This is sine 40, isn't it? So this term is going to be the same as that term, isn't it? See, only those two. If you join them, what do you get? Negative 4k1 and negative 4k1, you get negative 8 sine 40. You simplify that. Is there another one you can simplify? Senor? This and this, isn't it? Are you seeing that? So 4k2 cos 40 and 4k2 cos 40 you get plus 8 cos 40, isn't it? Are we together? These other ones are different. You are joining the terms which are the same. This is positive 4k2 cos 40, positive 4k2 cos 40, they are the same thing. So you get a total of positive 8k2 cos 40. Are you seeing that? These other ones are different. This one, negative 16. Negative 16k1 t. Negative 16k1 t cos 40. Then the other one, negative k2t sine 40. So we are done with this, isn't it? Then it is plus 16v. So positive 16 times v. What is your v? So your v is this, the whole of this term, isn't it? So positive 16 times the whole of v, what do you get? 16 times k1 plus 16k1t cos 40, 16 times k2 here plus 16k2t sine 40. Then the whole of it is equals to what? 16 cos 40. Is that okay? Are we together? Good. So after doing that, now you have to be very careful. Now look what I mean by you have to be very careful. Don't just compare any coefficients. You will get it wrong. Okay? Only compare the coefficient of what you are seeing on the other side. What are we seeing on the other side? Cos 40. So in the other side, it means we are going to compare the coefficient of 16 cos 40 plus 0 sine 40. Meaning, you are not going to compare the coefficients of the ones which are having t cos 40, the ones which are having t cos 40, t sine 40, because they are not t sine or cos is not on the other side of the equation. Are you getting what I'm trying to imply? You remember here we have the terms with the t sine 40. The other side of the equation, there is no term like t sine 40 or t cos 40. So you don't compare those coefficients. You are getting the argument? You compare the coefficient of what is on the other side. The other side we had cos 40. This 16 is a constant. So only the ones with cos 40, and because you know cos 40 and sin 40 goes together. Those are the coefficients you compare. These other ones you don't deal with. These ones with the t. We don't need these ones with the t. Are you seeing them? Are we together there? You don't deal with those ones with the t. So start by comparing the cos. This is This one is cos. Another one with cos. See only that. This one's with the t, we don't need. This one with the t, we don't need. This one with the t, we don't need. This one with the t, we don't need, isn't it? We need the ones without t on the right hand side of the equation. Is that understood?
Yes.
So here, 8k2 cos 40, you compare with 16 cos 40, you compare the coefficient, isn't it? So it means this coefficient 8k2 is equals to the coefficient here is 16, isn't it? Coefficient here is 16, coefficient here is 8k2. So what is that implies what? K2 is 2. Then what is K1? K1 is automatic 0. Because you are comparing the coefficient of sign. Negative 8k1 is equals to 0, meaning k1 will be 0. 0 divided by anything is 0, isn't it? Are we together? You only compare what is on that right hand side of the equation. What is not there, you ignore. This t, cos, t, c, they are not on the other side, you ignore them. Are we together? That is why when you are doing this differentiation, you have to be very careful because there's an instance when you are generating the terms we need, isn't it?
Yes.
Good. So can you now substitute that in your V? So what was your V? What was your V? V was K1 t cos 40. What is K1? 0. So it means the whole of this is 0, isn't it? Are we together? Then K2 t sine 40. So what is K2? 2. So it means V is 2. 2t sine 2t sine 40. So what have you found? You found u and v. So if you found u and v, it means you found x, isn't it? If you found u and v, you found x. So what was your x? Your x was the complementary function plus the particular integral. So x is equals to u, which is a cos 4, cos 40 plus b sine 4 t. So the whole of that is u, then plus v. V is plus 2t sine 40, meaning you are choosing the value of v because this particular integral will always be a term which are different from this, isn't it? Are we together? It will always be a term which is different from the other one. So start. Start the boundary conditions. When x is 2, t is 0, isn't it? So when we have dx over dt, meaning we need to differentiate this equation, isn't it? So if we differentiate this equation, differentiating x with respect to t, if you differentiate cos 40, you get negative 4 sine 40, then times your a which was there, isn't it? Then you come here, if you differentiate sine 40, you get positive 4 cos 40, then times your b which was there, isn't it? Are we together? Good. If you differentiate this, product rule, isn't it? Product rule. So there we have 2t sine 40. So you can let 2t to be u and sine 40 to be v, isn't it? So if you differentiate u, you get what? If you differentiate 2t, you get 2. And if you differentiate v, 4 cos 40. If you differentiate sine 40, you get 4 cos 40, isn't it? So what do we have in the product rule? uv plus uv, this is u prime, the other one is v prime, isn't it? So u prime times v, move. That is 2 times sine 40, meaning you are going to have plus 2 sine 40. Then u times v prime, 2t, u was 2t, isn't it? 2t times 4 cos 40 you get plus 8t cos 40. Have you seen the way we are using product rule? Very simple. Are we together? So from there you start by substituting the boundary condition in the two equations. Is that okay? Remember the solution is this x, but we are using both of them to get the value of a and b, isn't it? Yes, but you know very well this is the solution. All we need to get is the value of a and b, isn't it? So x is what? X is 2 is equals to t is what? 0. When t is 0, cos 0 is 1. You remain with a sin 0 is 0, the whole of this goes to 0, isn't it? Sin 0 is 0, the whole of that goes to 0. Are we together? Are we together? Yes. So you get a is 2. You are done. You move to the second equation. dx over dt is what? Is 4. So 4 is equals to t is 0. Sin 0, the whole of this goes to 0, isn't it? Cos 0 is 1. You remain with 4. 4b. Sin 0, everything there goes to 0, isn't it? Cos 0 is 1, isn't it? Yes. Even t is 0, the whole of this goes to 0 again, isn't it? Where you put t, the whole of this goes to 0. Sin 0 is 0. This is 1, you remain with 4b. This is 0. Meaning we just remain with 4b. So what is b? B is 1. So after finding the value of a and b, it means you found the solution. Yes. So you found a to be 2, b to be 1. So what is your solution? X. Where there is a, you put 2. And where there is b, you put 1. So a is 2. So we are going to get 2 cos 40 plus b. B is 1. So it is just plus sign. 40 plus 2t sine 40. And that is the solution of the given differential equation. Is that okay? That is the solution of the given differential equation.